Hey there, welcome to your very first flipped lesson. And so the goal of this lesson is I want you to take really good notes, and remember, you are taking notes for you. Your notes should be thorough enough so you can come back to this in a couple days or a week or even a couple months and look at your notes and remember what you're doing. So please take good notes, and at the end of your notes you have 3 problems for homework to do. So make sure that you do your work. So today I want to talk about graphing lines. In particular, I want to talk about a particular form of writing the equation of a line called slope-intercept form. I call this the working horse of linear equations. If you can get an equation to look like this, y equals mx plus b, where you could get the y all by itself, nothing in front of it, nothing on the left-hand side except the y, then graphing a line is pretty easy. This number, m, the number in front of the x, is a very special number for us. It represents the slope, and I'll remind you that that's the rise over the run. And the b, the number all by itself, in math we call that a constant. This b, that represents the y-intercept, where this line crosses the y-axis. So let's just dive in and let's try a problem on our own. Now remember, these notes are for you. So if I'm moving too fast in the video, which I will at times, pause the video and get caught up. So the first thing in your notes I want you to graph is this equation, y equals 2/3 x minus 5. And the first thing you might notice is that it is already in slope-intercept form. The y is all by itself. Nothing else is on the left-hand side with the y. So we can right away pull out the slope and the y-intercept. Now remember, the slope is the number in front of the x, the coefficient in front of the x. 2/3 is our slope. The y-intercept is the constant, the number that is not attached to any variable. In this case, it's -5. And so if I was going to graph this line, which we are, we always start with our y-intercept, in this case -5. So I'll go down 5 units on the y-axis and I'll put a point right there. And then I'll generate my other points using the slope. Remember, this number up here is the rise. It's how much we go up or down. And this number right here is the run. It's how much we go left to right. So from this point, I'm going to rise 2 and I'm going to run 3, and that gives me another point. And we can keep going. Up 2, right 3. Which, by the way, remember, positive 2/3 is also the same as -2 divided by -3. That's still a positive. And if I thought of my slope that way, I could say the rise from this point is down 2, and the run is negative, or to the left 3, and I would get that point. And once you have all your points set up, you can draw that straight line through all those points, and there it is. Let's try another one. Let's take a look at this equation. Again, notice it's already in slope-intercept form. The y is all by itself. So the slope we can just pull right out. The slope is the number in front of the x. The y-intercept, always the constant, the number that's by itself. In this case, that's a +2. So if I was going to graph this line right here, I could start out with my y-intercept at +2. So I'll go up 2 and make a point. And now let's figure out our slope. Well, notice the slope is negative. And when you have a negative, you have to choose. You could either put that negative with the number in the top, which would look like this, or you could put that negative with the number in the bottom, and it would look like this. What you don't do is you don't put the negative in both places. So if the negative is in the top, like we have here, my rise would be down 5. 1, 2, 3, 4, 5, and to the right 3. 1, 2, 3. If I put the negative in the bottom, from this point my rise would be up 5. 1, 2, 3, 4, 5, and to the left 3, and we would end up here. So once you have enough points that you fill up your whole grid, go ahead and take your ruler and draw a nice straight line connecting those points, and there you have it. Now, before we move on with kind of more complicated looking lines, I want to talk about 3 very special lines that you at one time were pretty good with in Algebra 1, but you may have forgotten. And these are those special lines. The first one is the line x equals 3. And I know you're thinking, ooh, whoa, heavens, we're missing the y value. And the y value isn't here. See, it doesn't matter what y is. All I care about is where x is 3. And if you look at this graph grid and think about x values being 3, remember the x-axis is the horizontal axis. And if I count to the right 3, that point right there is one point where x is 3. It's not the only point where, x is 3 here, x is 3 here, x is 3 here, x is 3 here. All I care about in this equation is the x value has to be 3. Doesn't matter what y is. X has to be 3. And in this case, if we plot all those points, we get that vertical line. This is a vertical line. And you may remember from algebra, this is very special slope. The slope is undefined. Here's another special line. Y equals 3. This time, notice the x is missing. So there is no x. All I care about is a y value that's 3. So I count up 3, and there's where y is 3. That's not the only spot. Y is also 3 here. Y is 3 here. Y is 3 all the way over here. It doesn't matter what x is. I just need y to be 3. And when we graph all those points, we get this horizontal line. And this horizontal line has a slope that's 0. Just 0 slope. It is totally flat. Whereas this line, the slope is undefined. It's so steep, we can't define it. Now there's another very special line. The third special line is this one, y equals x. And if you start plotting points where y equals x, pick a number for x. X could be 3. Well, if x is 3, y has to be 3. And that point is right here. Pick another number for x. X could be 2. Y has to be 2. That would be here. You could also graph this, besides picking numbers, because it's in slope-intercept form. The y-intercept is this number all by itself. Now you don't see it, but you know what's there. That number is a 0. So the y-intercept is a 0. The slope is the number in front of x, and in this case, the slope, or the m value, is 1. Now, I like my slopes to be fractions, so I'm going to write it as 1 over 1. So from this point, you go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Or you could call this negative 1 over negative 1. That's still a positive 1. Down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. Anyways, the line y equals x is this diagonal line cutting right through the origin. Well, there's just one more thing I want to talk about in today's notes. And that's what if you're given an equation that is not in slope-intercept form, but you have to graph it. Now we know this is a linear equation because the highest power of x and y is just 1. It's not squared, it's not cubed, it's not to the 4th. So this is going to be a line, so we need to get it in slope-intercept form. So how do you do that? Well, first of all, remember, slope-intercept form, y equals mx plus b. And to get it in slope-intercept form, it means I need to get this y all by itself. So to get this y all alone, first thing I'm going to do is get rid of that 3x. I'll subtract 3x from both sides. And when we do that, those 3x's cancel. On the left-hand side, we have 3y, and on the right-hand side, we have this, negative 3x and a positive 12. Now, we're not quite in slope-intercept form. The y has to be alone, and we've got that 3 in front of it. So to get rid of that 3, I'm going to divide both sides by 3. And when I do that, that goes away, and we have just the y on this side. Now over here on the right side, thanks to the distributive property, we have to divide that 3 into both terms. So on the right-hand side, we have to do negative 3x divided by 3. We also have to do 12 divided by 3. And when you clean that up, you get just y equals negative x, because those 3's divide and make 1, plus 4. And once you have that, the slope is the number right in front of x, and the number right in front of x is a negative 1, and the y-intercept is a 4. Now, there's one more problem in your notes. It's number 7. Why don't you pause the video and try to manipulate number 7 so it's in slope-intercept form, and then when you're done, come back to the video and see if you got it right. Well, hey, welcome back. So number 7 looks like this, and we're trying to put it in slope-intercept form. Remember, we want the y by itself. First thing I do, subtract 5x from both sides. And when I do that, boom, the 5x disappears from the left-hand side, and we're left with the 2y. And on the right-hand side, we have a negative 5x, and we have a positive 10. We're almost there. To get this in slope-intercept form, that 2 can't be there. So we'll divide both sides by 2. These 2's make 1, so the y's all by itself. And remember, over here, you have to divide that 2 into both terms. It's really the distributive property. So you get y equals, on the left, on the right, you have negative 5 divided by 2. Keep it as a fraction. Don't write it as a mixed number. Don't write it as a decimal. Remember, slope is the rise over the run. The fraction means something. And then our y-intercept in this case is a 5. Slope, y-intercept. Well, there are, and I think I misspoke earlier, there are actually 4 problems for you to do at the bottom of your guided notes. So tonight, I want you to get those 4 problems done and have them done by class tomorrow. Have a great night.